So thank you. I appreciate you coming here. My name's David Nally. At AWS, I am the director of open source software strategy and marketing and work on leading that. But I'm also the president of the Apache Software Foundation, which means if you're a security practitioner, I'm the problem. Hi, it's me. That means I'm the person who, when Log4Shell broke, you should be blaming me for making you work nights and weekends, and I'm sorry for that. Last year, when Mark and I had a chance to talk about open source software security.
Raise your hand if you were with us last year in Anaheim, because he gave us similar. Oh, that's good. Very few
okay.
people. Great. Okay, good.
That means that people didn't like our content last year, and they didn't come back this year. So we talked about this, and Mark kind of made an unplanned disclosure. He told all of the security practitioners in the room that I was the president of the ASF, which is something that was not in the slides. This year it made it into the slides because I didn't have any control over the slides. And so this is what happens when you don't have slide content. It's, hi, I'm your problem.
And my name is Mark Ryland. Hello, everybody. I'm the director on the Amazon security team, and I'm the solution. Not really. But in the security organization, we want to collaborate with our open source colleagues, and together we want to come up with the right solutions for that. So welcome to the talk. It's great to have you here.
Yeah, so one thing that Log4Shell drove home for me was that open source was pervasive. I knew, I've been working in open source for 2 decades. I knew that open source was everywhere, but I didn't know what pervasive meant until Log4Shell broke. And then there were so many people screaming at me. And it wasn't just about people writing software. It's people who are deploying hemoglobin analysis tools that are hardware pieces. People with satellites in space were suddenly coming to me and saying, how do you expect me to upgrade this in place? And is someone going to exploit Log4j while my satellite is in orbit? Open source really has become pervasive and ubiquitous. And just to dive into that, it's not just washing machines. That's great. I guess I'm glad that there's software in washing machines, maybe. I'm not sure it gets clothes any cleaner. But, when we're having to have CISA disclose that your washing machine is vulnerable to Log4Shell, it really does talk about how deeply pervasive open source has become. And Sonatype, who makes Synopsys, who makes the software composition analysis tool Black Duck, when they look at the code bases they're scanning, their most recent report in 2024 said that 96% of the code bases that they scanned contained open source software. That feels a little inaccurate to me. I'm guessing plus or minus 3%. Definitely plus side, though. So probably 99% is a more realistic number. The more interesting thing to me is they said of that 96% that do contain open source software, 78% by volume is open source. So for any given code base that they scanned, 78% by lines of code is open source software. And partly this is a sign of success, right? I mean, we built open source and we ship open source software so that people do not have to reinvent the wheel. We just didn't realize they were going to do 78% of the world was non-reinvention of the wheel, and the balance is what we're actually innovating. But I want to ask the question of what does pervasiveness look like? Because this is a lot more complex, particularly if you're from an application security perspective, if you work in a PCERT or an environment like that. And so I'm going to tell you about some dependency trees for some open source software. So Apache Airflow has over 900 dependencies, if you include all the transitive dependencies. 900 dependencies. That's what pervasiveness looks like. And that's not uncommon. I've worked in commercial software companies where their enterprise product would have 800, 900, 1,200 dependencies, and that is their dependency tree for a single product. That's what pervasiveness looks like. It's everywhere, and it's a huge chunk of the overall code base, and it's not one or two dependencies. It's 800 or 900. Now, specifically, a lot of people used to come and tell me, when I worked in a PCERT, they used to come and tell me, I've only got 10 dependencies. And my first reaction was to laugh, because one of their dependencies would be Qt or Qt. Anyone want to throw out a guess of how many dependencies Qt has? Not quite. They're actually very conservative and very heavily curated given the size of the code base, 150. But if you count that one, you've now got several orders of magnitude more dependencies than you think you do. And so we have this massive dependency on open source that is really unseen by us. We don't think of those transitive dependencies. So we're gonna talk a little bit about some of the challenges that we have seen over the course of our careers, some of the solutions, some of the things that AWS is working on, but more importantly for you, things that you should be doing and thinking about as you're building out applications and building out software.
I want to tie together this point you just made with your previous slide, because in the previous point you made, you said Black Ducks detect 76% of your code is actually, open source. But that's not code in your repository, right? So you think it's 2% of your code, but really it's the dependencies that are chained out from the things that you're importing that inflate that number. And that's part of the problem we're talking about, is it's not even that visible to people. And the lack of visibility is part of the challenge, and that's something we all need to get better about.
Yeah. When you think in source code terms, it definitely is occluded from view, because that's just a dependency line in a Maven doc, or it's an import statement in Python, and you don't treat that as, oh, I've got some massive 200 entry dependency tree because I did one import statement.
Right, exactly.
So let's talk about a couple of things that have happened. This is not exhaustive. We're just talking about some examples because we think that it's useful to set context. We want to start with
some highlights, if you will.
Yes. These are the things you should be excited about. So Debian in 2008, they had a problem with OpenSSH, except it wasn't a problem with OpenSSH. There was no vulnerability in OpenSSH. Instead, the packager of the software, the person who was creating that deb file, he wanted to run some local tests. And so he neutered the random number generator. Now, as you might expect, when you are creating things like SSH keys, that depends upon, at least if you want them to be well guarded, that depends upon a certain amount of randomness in that number generation. And that wasn't there. And this had been shipping for some time, and no one noticed it. So this is not an actual problem in the software. This is a problem in the packaging, meaning that the original author of OpenSSH, or authors, they had no idea that this was done. So vulnerability created because someone wanted to make testing easier and didn't back out their changes. An entire series of Debian releases, and then Ubuntu releases, and then downstream from those two distributions released this software. Anybody here have a key that they had to replace because of this? I see a number of hands. I had to replace at least one. I remember getting locked out of a bunch of systems I had shell access to because we had to create tools to detect if our SSH keys were actually generated with any random numbers or not. And so this is an attack on the supply chain that was not malicious, that had bad outcomes, that we had to do a lot of work to remediate, and the original open source authors had no culpability in it at all.
Let's fast forward 6 years, 2014 now. And who remembers Heartbleed? Raise your hand if you, okay, now we're getting some nice traction there. Heartbleed was, as you recall, a bug in OpenSSL that when using a relatively little used feature of the TLS protocol, I think it was a continuation flag, there was just a bug that would send you back memory from the server that happened to be sort of nearby the memory that was supposed to be sent back. So lots of interesting data, often things like private keys would show up. This was just one of those classic 0 days, burst onto the scene. A whole industry, we had to scramble for patching and so forth. And the good news for AWS at the time, I was actually working at AWS way back when. I've been here almost 13 years. We weren't actually impacted in our API endpoints for sort of historical reasons. We weren't using the software there. But we did run this very popular service called Elastic Load Balancer. Ever heard of that? And Elastic Load Balancer servers were using the vulnerable software. So this was one of the very first times we've ever had to, we've only done this a few times, really like turn the knob towards speed against safety and do a massive redeployment of all of our load balancing instances. And within something like little over 24 hours, we literally patched 1 million hosts. Thanks to the automation that we have in the cloud, we could do stuff like that. But then I would talk to customers months later, and they were still struggling to get all their systems patched because they didn't have the automation to detect and to respond. So it was a huge challenge for the industry. And also, I think there's another important footnote to drop here, which is this is when one of the first times I think I remember AWS really scratching its head hard and saying, you know what, we better start investing in some of these open source primitives that have such a broad impact on the industry, and without at all denigrating the hard work done by other people. They had working on for many years, often as volunteers, under lots of constraints, poorly funded, et cetera, et cetera. Well, that alone is not good. That's kind of unhealthy. So we'll talk a lot about how we want to address that phenomenon. But we also decided at that point to build our own implementation of TLS, which many of you know as S2N. So S2N is a replacement, which is open source, freely available, very minimalistic, super small. Took out a ton of features that almost no one uses because features means code, which means bugs. Built a ton of testing as well. So the test lines per code outnumbers the implementation 7 to 1. There's a 7 to 1 ratio, the test source code versus the implementation source code. And we applied, this was one of the first times we did this, applied formal verification techniques. So we began to use the tools that computer scientists had developed to make logic proofs about code and run those against the code. And every time you do a check-in, there's what's called a SMT solver, runs against the code, makes sure that it meets certain logic constraints, rejects your check-in if it doesn't pass the logic tests. And that way we've been able to build and operate and give away a very high-quality, very small, and very focused implementation of TLS. And we'll talk about how we've extended that since then, but that was an
Can we talk a little bit about formal verification? Because I think it's such a cool, geeky topic.
Yep.
But it's not one that, it's never going to be on the front of InfoWorld or TechCrunch because, it's a really deep, geeky topic. So formal verification is when you try and use logical or mathematical proofs to establish how a system performs. And we don't mean how it performs normally. We're looking for what are the possible alternatives of how this software can react. And you can't use formal verification everywhere, and there's certainly places where it's easier to use than not. But generally, you're looking for one of 3 outcomes. Either A, you can prove a specific behavior. B, you can disprove that behavior happens, i.e. something goes wrong. Or you can learn that you don't know if you can prove it or not. And that's a place to go dig deeper. The problem is that at Amazon scale, where you might have a 1 in a million or 1 in a billion chance of running into a bug, that may be 15 times an hour. And so running into those types of bugs that threaten availability or data, the cleanliness of data and keeping it clean and available, that's just not acceptable. And so for our most heavily used systems, the systems that must be correct, certainly we are applying unit tests and functional tests and things like that. But we go above and beyond using formal verification and automated reasoning so that we can reason using logic about how a system will perform or will not perform. And we do that as kind of a belt and suspenders because, again, a once in a billion activity can happen multiple times an hour at Amazon scale. So super valuable thing. We'll talk more about formal verification later, but if you're looking for a cool, really geeky rabbit hole, automated reasoning and formal verification will keep you entertained for a long while.
And by the way, we wanted to turn it into a non-rabbit hole and make it much more common in the industry. So we're developing training. We have a bunch of tools we've open sourced. We're building services and so forth and so on. So over the years, you'll begin to see something where we want the average developer, just like the average developer now is having to interact with Gen AI systems. That's the thing they didn't do a few years ago. We want to get that same point with formal methods, which are very complementary in many regards to AI.
So that was my way of trying to delay talking about Log4Shell.
Nice try. We've got to talk about it.
So Log4Shell, we learned about that in late December 2021, or the world learned about it then. And really bad vulnerability. My favorite quote from that is Jen Easterly, who is the director of the Cybersecurity and Infrastructure Security Agency in the US, who said that it was the worst security vulnerability she had seen in her career, which means I was certainly hitting a high mark there. So it actually came about, the actual vulnerability was introduced in 2013 and lay undiscovered, we assume, for many, many years. So 8 years that it went undiscovered. And it was actually a feature. Like somebody wrote this as a feature. So this wasn't even a bug, right? The system was working as intended. We just never planned, never thought that those types of systems would be exposed to an antagonistic internet when it was originally written. And so this unintended consequence of having this great feature, I'm kidding, but this feature that somebody actually asked for and wrote, then weaponized and used in a way
who wouldn't want to update
intended.
your log files with arbitrary information from your LDAP system? I mean, that sounds really useful to me.
It does sound really useful, right? I may want a different log level if I'm seeing input from you than me.
Absolutely.
So I mean, there was a legitimate.
It wasn't crazy.
path.
That's my only point.
Yeah, it wasn't crazy.
It was just really wrong.
Also, the vulnerability required you to have multiple components in place, right? So you had to have Gendy in your environment, which a lot of environments didn't have. So if you had looked at Log4Shell, it wouldn't have been obvious that this was even present. So really complex, multi-layered feature that enabled lots of security problems.
And the latest and greatest, raise your hand if you've heard about XZ, this crowd. Yeah, pretty much, a majority have. So this was discovered just a couple months ago. And this was quite different. And I think everyone that we've talked about so far was either unintentional or unclear in terms of provenance.
Yeah.
But in this case, absolutely clear, malicious actor setting out systematically over a period of time, patiently laying the groundwork to become a trusted member of an open source community of a very small, seemingly unimportant component of the Linux operating system, but knowing enough about the complex system architecture to know that if they could, through this very small, backwater component, introduce some code, especially binary code, into the system, they could hook some things and they could do some very, very serious damage. So they literally show up at an undersourced, underfunded project with one developer who hasn't updated the code in a while, and they say, hey, can we help? And then pretty soon they create personas that are asking for more features. Hey, could you please add this feature? So now you not only have a volunteer. Remember the old saying on the internet, nobody knows you're a dog? Well, on the internet, nobody knows you're an attacker because everybody shows up to help, right? It's an environment where help is desirable and wanted, right? So if I show up to help and then someone else who seems completely unrelated to me shows up and says, boy, I could really use the feature that this guy, hey, I noticed that they mentioned in the public repository that they'd be willing to add this feature. That's amazing. I'd love to use that feature. Pretty soon a couple more people show up saying they'd like to use the feature. And eventually, this developer is like, okay, I mean, it looks like there's demand for the feature. Then I'll give this, entity, this persona, some ability to update code. And then what happened were a series of pretty sophisticated, obfuscated steps for inserting the feature, but also adding things into the test code, which were actually binaries, which could then actually hook things. And in the end, when you built and deployed a system with this bug, the malware had access to the SSHD authentication routines. Okay, so anybody who knew what to do could log in arbitrarily to any system that had this bug in it. So it was a pretty massive backdoor, and all very clearly, intentionally planned over a long period of time. It was about 3 years, I think, altogether.
About 2.5 years, yeah.
So now the assumption is that's a nation-state attack. Well, it doesn't have to be. It could just be some very strongly commercially motivated actor, but some sophisticated actor with long-term plans did this. Now, it was caught before it was widely deployed. So, hey, you could say this is a success story. The system worked. How did it work? Well, there's a lot of assiduous engineers out there, and someone was testing the latest version of this code, and it ran slower. According to his test, that was significantly slower for certain basic operations. Like, what's that all about? Get out your debugger, look at some of the code. Whoa, wait a second, what's going on here? Announce to the world, everybody, 4-alarm fire, get the code out of the distributions. Most people weren't impacted because it was too early in the kind of release cycle. So again, success story. Compare this with proprietary software. Casting no aspersions on our friends, but hey, SolarWinds, proprietary software. Nobody had the ability, no one outside the company would have been able to analyze the changes that had been made to understand the performance impacts or other ancillary impacts of the malware that's inside the binary. It's just not possible to do that unless you are an employee of SolarWinds. So this is in some ways good news, but it also scares the heck out of everybody. So let's just get it out there, and we'll talk about how. And by the way, there's been other similar attacks that have been detected and blocked. Similar pattern, friendly developer shows up, offers to help, obscure piece of software, but maybe close to some important software. So forewarned is forearmed, they say. So now everybody in the open source community is very conscious of this risk. Doesn't mean it's zero, but it's now probably decreased somewhat because of this experience. So again, scary. Success story, you decide, but we'll keep going.
I do want to call out, though, you talked about the performance hit. The performance hit was 200 milliseconds.
Yeah, that's pretty awesome.
Would you have investigated a 200 millisecond performance degradation? Because I wouldn't have. But it brings up the cuckoo's egg, Cliff Stoll, right? Yeah. Where he was looking at very small chunks of time that was errored in billing in a billing system at a university.
A couple of cents off.
Yeah, that didn't matter to anyone, and yet he found a nation state performing an attack on the U.S. military. That's a great book if you haven't read it. But one of the things that Mark and I get to do is we have a dedicated session every few weeks where we talk about open source supply chain security, and we pull in security engineers, software developers, and others to talk about it. And a while back, we started getting worried, realizing that there are choke points in package repositories. And then Mark goes off to the White House. He lives in the D.C. area, and he gets invited to the White House on a somewhat regular occasion. And I start getting text messages from someone at the Linux Foundation saying, Mark is talking about package repositories, and it's scaring the government people.
Yes.
And so he essentially told the story of how we had done some threat analysis against some of these package repositories, trying to figure out just how risky they were and what kind of risk that represented to our customers and to us. So one of these on the screen here, it was maintained by 2 volunteers. One of them was a full-time software engineer. He had a real job, but he loved the language so much that he worked to maintain it. Another was a student, a sophomore in college in Europe. And that is where the entire world consumed packages for that one language.
A very popular language.
So think about that. We talked about some of these earlier vulnerabilities where the software that was actually shipped from the Git repository was not at risk. It had been tampered with downstream, whether that's XZ or OpenSSH in the Debian case. Think about these package repositories as an attractive attack target. So AWS started, obviously we're doing the threat analysis. We're trying to figure out marshals. So we worked with the Rust Foundation, we worked with the Python package index, and funded a security engineer who's here in the room, and I will not out him, but he's here in the room. He's doing work to help mitigate the risk to the Python package index. We started doing the same thing with Ruby gems. And of course, we've been working with Maven Central for a longer period of time, and think that they've got a lot of systems in place that are right. But a lot of these attacks are typo squatting, which means all you have to do is either you make a typo when you're trying to import a dependency, or you're not smart enough at 2 a.m. when you're trying to get that code out because you've got to ship the next morning to discern between com.amazon.sdk or com.am.
Wait, you're using a bad example.
I am. I'm using a horrible example, aren't I?
Yeah, so...
I'm too Java-centric, aren't I?
Java has a real benefit here, folks, because years and years ago, in fact, I was working at Microsoft at the time. This is in the 1990s. And there was this whole industry thing at the time about, a big industry were about component architectures and distributed object systems. Anybody remember Corba? Everybody remember DCOM? Okay, I worked on all that stuff. So Microsoft and Sun chose totally different ways of creating completely unique names that could be used industry-wide, but were guaranteed to be unique. Sun chose by far the better option, by the way. Microsoft chose UUIDs, giant numbers. Perfect. I mean, it really is perfect. It solves the problem. Your giant number will never collide with my giant number. It's true. I mean, it might, but it's extremely improbable. But they're not human readable. So you always have to translate them or keep some sort of a mapping between a human readable name and the giant number. Sun did something very clever. They said, is there any global namespace out there in the world that's moderately well managed and has things like dispute resolution about who owns names? And, guess what? There's this thing called DNS. What do you know? If I acquire Microsoft.com, they can kick me off that name because the global DNS system has an arbitration mechanism. Aha, now we have a solution. By just flipping the names backwards, we can use DNS names to uniquely name software artifacts that are guaranteed not to collide unless you, stupid Amazon, stupid enterprise, don't manage your internal namespace properly. You can screw this up, but that's your problem. The rest of the world cannot take com.amazon.foo, because you manage that. So this is a beautiful thing, and I wish every language did this. And maybe it's too late, maybe it's not too late, but we should all move to these kinds of things where you can create names that are human readable, but can't easily be faked.
I agree. And if you work on a language today, please try and integrate a namespace so that we don't have Amazon and Amazon competing for each other.
Or Unicode. Remember what is it called? Homoglyphs or something? Yep. Where like in Unicode, these two words will look exactly the same, but they're completely different values in the Unicode. That stuff would drive us all crazy. We have to get ahead of that.
Yes, agreed. Namespace would be lovely in every language today. Java, and in particular the Maven Central package repository, has really strong controls. So they know, for instance, that org.apache can only come from the Apache Software Foundation, and they have a dedicated means for people to actually get access to that namespace. Same thing for com.amazon. So I'm presenting some data from the Python package index. I did not know that the security engineer for the Python package index was going to be here. But they have removed...
Get him up here. No, just kidding.
Involuntary speaker. They have removed tens of thousands of malicious, I'm going to call them malicious, because whether they intend to be malicious or not, they are. And whether that is people having confusion over a name, or alternatively, people actively trying to subvert the system to inject malware in. They've had to remove tens of thousands. Now, it's getting better. They're building systems and building mechanisms. And so you see this line taking a huge nosedive. But whether it's dependency confusion, where people have very similar names, or it's malware, did anybody have any idea that there were tens of thousands of effectively supply chain attacks on package repositories when they came in this room?
Well, now you know.
Now you know.
But don't panic. It's going to be okay.
Yeah, don't panic. It's we're actively taking steps, and by we, I mean the open source community is actively taking steps. AWS is trying to help fund some of those efforts to improve both the resiliency and the structure and the mechanisms available to respond to these types of attacks. So when we look at NPM, the Python package index, which, I'm sorry, I want to call that PyPy. In my mind, that's PyPy. I know it's wrong. If you're from the Python community, just indulge me for another 30 minutes.
Is it AMI or AMI?
That particular holy war we will not get into, but it is VI and not Emacs. So if we look at the malicious packages detected in NPM, PyPy, and Ruby gems, again, 10,000 plus most years. The Reversing Labs actually produced some data that said that 11,000 were detected. So malicious packages that were able to be detected in automated manner. And we're seeing that increase at a rate of 28% per year. That should be a frightening thing, especially for these relatively underfunded package repositories.
I stole your famous slide here. Ready?
Yeah, sure. Oh. People have thoughts on this? Is banning open source realistic?
No.
I will tell you
not going to happen, folks.
After the screaming stopped with Log4Shell, which took some months, I then was interacting with a lot of companies who were telling me, you know what, we've just made the decision that we're going to have to rip out Log4j. We've decided that it's just too risky. We can't do that anymore. I'm like, okay, so what that means is you're going to have to build an equivalent that you're going to write, and then you're going to own the security response for. And then you're going to have to move it into production. And then you're going to have to update all of the software that was using Log4j to use the new interfaces for your software. And that's
from now until the end of time.
Forever. That's technical debt you can never pay off. You're only paying the interest in eternity. And I would go back and check in a few months and say, hey, where do you stand on that? And they would say, well, we looked at it, but the reality is Log4j is just the tip of the iceberg, and we can't replace it all. Open source is too big to replace. And so we kind of feel like we don't have a choice but to make sure that open source is successful. I'm like, well, that's great. We need a plan for open source to be successful. But it really comes down to risk versus reward. And the safest thing is not to write software. No vulnerabilities if there's no software, right? But
yeah, this is where I have to speak up because I work in the security business.
Yeah,
so
absolutely.
But interestingly, I'm not like an old timer. I didn't get into security until fairly late in my career. You can see all the gray hair, and that's because I worked in our cloud division that's sold to governments, and so that I had to be a security expert. That's all they ever cared about. However, once I got into this area, and I was always hearing these people talk about risk. Oh, there's my risk manager. I've got the risk analysis, got a risk framework, risk. Always talking about risk, and I'm a new guy. I'm like, where's the benefit? Like, it's like talking about black and never talking about white, or vice versa. You shouldn't do anything that causes risk unless it provides a benefit. Then it makes sense to do it. So the question is not whether there's risk. The question is, do the benefits outweigh the risk? That's always the question. And as I kind of hammer this home to security people, they're like, oh, yeah, well, that's what we meant. I mean, we just didn't say benefit. And I'm like, okay, well, please, can we just get in the habit of saying benefit whenever we say risk, or at least once in a slide deck on 25 slides, risk, benefits somewhere, because that's what this is all about. So really, in some ways, that's what it comes down to. There's the negative case, which is, oh, we're stuck with open source, we're never going to get rid of it. But there's a positive case, which is we get massive benefit from the use of open source software, and it creates risk. So what our job is to drive down the risk as much as we feasibly can, try to maintain as many benefits as we can, and that's the way forward, as opposed to these kind of unrealistic.
We can't eliminate risk. We should be trying to mitigate risk where we can, but it always has to be balanced, and I think that's the real trade-off. So security professionals are trying to minimize that for us, right? And that's what the Amazon Security Organization is doing, right? They can't eliminate all the risks. We're trying to figure out what the right balance is.
Are you ready for our next zinger slide? Okay, the next zinger slide.
Can I? Okay, never mind.
Let's hear it for generative AI. We can fix everything.
So, there's a mandate that every talk has to talk about generative AI. This is our token slide.
No, seriously. Super valuable technology. Don't get us wrong. We can be a little snarky, but there's all kinds of powerful use cases. We're seeing big improvements in a number of security tools. I would say at a minimum, generative AI is awesome at translation. And I mean that literally and figuratively. Literally, as in, we have a Japanese colleague. She says, I used to write my weekly reports in English, and now I don't. I write them in Japanese. I put them into a good Gen AI system, and it writes much better English than I can write, even though she's quite, literate or fluent in English. And that's massively increased her efficiency and improved her workflow, and her manager gets a better report. That's amazing, and we should all be doing things like that to take a benefit. And now let's extend the word translation a little bit further. How many times have you had some very sharp or bright person who has some really analytic mind and asks good questions, but they don't know SQL, or they don't know whatever query language du jour? These tools can translate their smart English questions into specific, actionable computerese and get back results amazingly well. Super good at that. So all security analysts, their world will be revolutionized by this technology. So there's a lot of upside, huge benefit. But now we can turn towards, well, will it fix all our bugs? It can help, but no. I mean, ultimately, the generative AI code generation systems, we'll work at it, we'll get them better. They'll get quite good. They're already quite good. They'll get better. But they do have hallucination. They create errors, and it still requires some human expertise to understand the significance, the concepts, the meaning, make sure the code's properly integrated, and so forth. So there's, this can be very helpful, but it's certainly not the panacea. It's not going to fix all our problems.
I will say the one use case that I'm really excited about is that of automating upgrades. Right? We're all terrified of upgrading software. Generative AI does have some success stories here, especially upgrading from Java 8 to Java 13 or 17.
Yep.
And being able to do that at speed with tests created both before and after to verify that nothing critical broke. That's exciting to me. And I think when we talk about needing to have the ability to patch quickly, I think generative AI is actually going to speed up incident response by helping us to patch more quickly.
Yep. That's a good example. So if you think about, if you're like us here at AWS, you really want healthy projects. I mean, again, the key to open source is healthy projects. But what does that mean? So there's, over the years, people develop these sort of common sense concepts of like, well, if there's more active it is, that's a good sign. Like if somebody hasn't checked in code for 2 or 3, 5 years, that's not a sign of good health. And what if we need to make some changes? Who's going to have the expertise? So, speed of updates, frequency of updates. There's many good signs about healthy. Larger communities are healthier than smaller ones. People who take security seriously in the project. So like if you see a system where all the developers are using multi-factor authentication, that's a very good sign. That means they're aware, they're conscious. So there's a whole lot of these factors that have been over the years, I'd say, somewhat informal, but in people's minds as they developed practices and best practices in this area. So one of the things that we've been really excited about and worked with the broader community through the OpenSSF on is this idea of can we measure this more objectively? And so I really want to give a strong plug for this project called the Scorecards Project. So this is an open source project about open source software. And what it does is it actually goes through and it checks about 15 or 20 objective criteria about projects that it can read the code, so in GitHub or GitLab and a few other platforms. And it will assess the health of a project using objective criteria. Now, of course, you could have a really good project that, it's not perfect, obviously, right? It's probabilistic, but it's a very strong indicator of good health if you do things like use MFA, if your code check-ins involve running static code analysis, if you have two-person rules for every check-in. There's just a whole long list of objective criteria that you can figure out from looking at someone's repo and then publish a scorecard about it. And then people will react positively. It creates a positive feedback loop in the sense that developers who really love their project and are invested in it want it to be successful. They're like, whoa, my score is not that great, and it wouldn't be that hard if I just added these 3 things, and then I get a great score. So you want to create those positive. I don't know about you, but in our company, if you put up a dashboard with all the vice presidents about how well maintained something is or how well patched it is, man, internal competition is great. People they call up all the developers, hey, why am I the lowest scoring team of anybody in the company? And that same kind of thing happens in the open source world, at least in a general sense. Obviously, we're not trying to literally create competition, but people enjoy being part of healthy communities, and this is an indicator of health. So we're really excited about this and strongly suggest you take a look at it.
So we really want to talk, though, about what you, as people who are building systems, maintaining and securing systems, should be expecting and doing. So what you should be expecting from an open source project is that they've got a bunch of systems in place. They can sign their code, they can produce an SBOM and share it with you. They can actually reply to and fix security issues. All of those should be things that you actually expect from a project, along with high-quality software and things that are actually useful for you. You're looking for evidence of this good hygiene or this good health, and this is what you should be expecting from your open source projects. But it's not just the open source project's responsibility. You take on some of that responsibility when you consume. And Mark, you want to talk about the developer side?
Yeah, and I think you reminded me of something that we've talked about quite a lot with government regulators who say, we need to regulate this market. It's creating risk, blah, blah, blah. And they tend to focus on the producer of the open source rather than the consumer. Just in natural, because if you're used to dealing with car manufacturers, right, you don't think about people buying cars, you think about but this is a different kind of market, right? Usually the consumers have a lot more money and power than the producers do in many of these scenarios. So you really need to put some responsibility on the consumers and maybe give a little bit of a break to the developers, or at least create incentives for them to do their work well, but recognize that often they're under-resourced, underfunded, and so forth. So this is why the consuming side is super important in this ecosystem. Absolutely,
I think we at AWS, we talk about the shared responsibility model where we have responsibility to make sure that things are secure in the cloud, but that can only go so far because the customer has so many options that they can choose, firewall ports they can open, methods of login that they can enable. And so it has to be a shared dependency. There's a very similar system here, right? Where as a developer, when you're taking on a dependency, you have to take on some ownership. Mark's going to talk a little bit about how Amazon thinks about that in a minute. But it is not I decided to take this thing, it's well known and it's well maintained, and I don't have to worry about it. You can't get away with that. And behave responsibly.
And another point that's implicit in what we said before, but let's make it very explicit. This is not a dual-sided market. Remember the dependency chain?
Yeah.
The consumer of my open source project, well, I'm a consumer of the dependencies that I have, and they're a consumer of the dependencies that they have. So this is a multi-layered environment, and we all need to take our shared responsibility across those dependency chains. And if you're the primordial library that doesn't depend on anything and everybody depends on you, that's a pretty important role that you play, and that we should all be aware of it and help you be successful, because we're building on top of that little Lego down at the bottom. So
absolutely. So I want to talk about a story of failure. And I know we talked about Log4Shell, and everybody groaned. Everybody has bad memories from those weeks in December. This shows this month, 30% of the downloads today of Log4j are for a version of Log4j that is vulnerable to Log4Shell.
That's this month.
This month.
Well, last month probably. May.
Yeah, May's the last. You're right.
Yeah.
Within the last month. Depending upon what day you go and actually look at these stats, they've got a real-time counter for the last day. I've seen that as high as 35% on a single day. 35% of the downloads of Log4j are picking up a version that is vulnerable to what Jen Easterly described as the worst security vulnerability she's seen in her career. This is the most publicized security incident that I ever recall, broader than Heartbleed. I don't recall the OpenSSL developers being dragged before Congress. I don't recall them standing up a cyber safety review board and then holding a hearing to investigate the response to Log4Shell. That happened for Log4Shell. And yet today, 30% of the downloads from Maven Central.
Okay, now you say, how is this possible? How is this possible? And the answer is, we have taught us generations of software developers to do the right thing, which is never ship and rely on software that you've never tested. So once you pin your code to some version of a code, I mean, encourage you to update when you get around to it, but whatever you do, don't depend on some variable. It's a pointer to the latest version, because it will break your code. So although this is a horrible statistic, and we got to fix this, again, it's not crazy that it does this, because basically all this says is there's a bunch of software out there that's not getting updated regularly, or the developers are overburdened and they just are like, this can't be that important. They're just not dealing with the fact that you've got to upgrade and test the new version. So painful, but it's not completely illogical.
We do have this concept of, if it's not broke, don't fix it. And we did tell generations of developers to pin their dependencies. My concern is that we have essentially told developers, you pin the dependency and then you don't have to worry about it. Yeah. Or in this case, you pin a dependency and you're carrying one of the worst vulnerabilities, at least in our lifetimes.
Yep. Now, a lot of what we've been saying is the story of software dependencies where you have one address space and you're loading in all these libraries and you're running along. Now, there has been a big change going on in the industry, in case you haven't noticed, called microservices. And although it's not a panacea and can't solve all these problems, at least be aware of and factor in this concept that if your packaging and consumption technology is, for example, some little containers who talk to each other over a network interface, could be a loopback address, right? Could be the local host. And if you maintain version, if you version your software in such a manner that you can support both old clients and newer clients and keep version numbers in the protocol, in the network protocol, this can really decouple software in a much better way than we traditionally have in these single process types of models. So you can actually update things without breaking anybody because you support both. So if you look at, just to give you a very salient example, how many people know how API versions are done in AWS on our public APIs? Think about that. So there is a version number in every single network request. And that version number is a date. It's ISO standard day. By the way, that means we can't update our software more than once a day, but It's okay, at least in a non-backward compatible way. That's the point. So when the server receives the client request, it knows the semantic and syntactic expectations of the client because it has a version number in there. And if it's an AWS service, believe me, we would not accept a service team saying, "Oh, we're not going to support 2 or 3 year old software. Forget that noise." No, they have to keep that semantic contract. But meanwhile, they can change their software a lot, and they can upgrade it. They can rewrite it in a different language. They can do whatever they want. So the notion of microservices and how software interacts with each other, again, not a panacea, but think about it as a kind of counterfactor in a lot of the things we've been talking about. We can develop some of the technologies in such a way that when we do have dependencies, they can be much more loosely coupled with one another, if to the extent that we can rely on things like microservice boundaries rather than in-memory loading of libraries.
I think one thing that matters a lot to me when we talk about currency is not necessarily that you chase every single version that's released. A lot of times those additional versions don't actually matter to you. But you need the ability to upgrade rapidly. And we've certainly seen teams that have struggled and said, "Oh, well, it's going to take us 18 months to upgrade to a new version of an open source problem." That's an issue. That's telling us that you don't have good enough hygiene on your own development practices if it takes you that long to validate, test, and ship an updated version. So I'm not saying you need to chase every version. You certainly need to, though, be thinking about how do I enable myself that if there is another Log4Shell, that I've got an easy path to upgrade.
Maybe the way we do versioning is all broken in the industry because it's a linear number that increases, monotonically. And maybe we ought to have 2 or 3 different numbering systems, one of which is, I promised to be backwards compatible, but I fixed a critical bug. And then you could pin yourself to the latest version that's a sort of a vector from the version that you tested with. I don't think we've invented that technology yet, but it seems like we ought to perhaps.
We have a lot of problems, a lot of difficult problems in software development that are certainly a challenge. But frankly, a lot of
You're not going to go with me to design a new system on stage here? I'm just kidding.
I mean, we don't even have a whiteboard.
This was not in our talk track, by the way. I just made this up.
So a lot of this, though, comes down to how do you choose what dependencies you're going to have? Are you going to swipe left or swipe right on a dependency? How are you evaluating whether a dependency is worth your time or not? And hopefully you're doing this a little more seriously than you might with app-based staging, because these are long-term relationships, right? So I've got a quick story here about some dependency trees. The folks at the Internet Security Research Group run a project called Proximo. Proximo is about working on memory safety, and they're rewriting some applications that are incredibly sensitive. And so in 2023, AWS funded some work on a rewrite of sudo and SU because we thought, this is a critical feature, and we would like to see that rewritten in a memory-safe language like Rust. They did that work, and they brought it back, and there were 135 dependencies. That created a lot of problems for uptake because if you're packaging this for an operating system, you also have to package the 135 dependencies, which means that's a ton of work. So we grumbled a little bit about that. The folks at ISRG immediately recognized what was going on, and they reduced the dependency load this year that they announced, 3 dependencies for sudo rs from 135. That's some real software engineering work, right? That's not just getting something thrown together and making it work. That's actually figuring out what do you actually need, what is critical for the software to run, and then only taking those dependencies. They did great work on this, and it only increased the total source code for the sudo rs project by just a couple of %, which is stunning. That means they didn't just
That's the key point there, right?
ingest
That
everything.
statistic would be like, oh, no big deal. They just went and rewrote all these dependencies, and now they have a massive amount of source code they have to maintain. But that was the key thing, was by careful analysis of what they really, really needed to depend on and clever engineering, they reduced it without a big bloat in their code, which is awesome.
Yep.
All right.
So we care about open source. It's what AWS was built on. AWS would not exist today if it weren't for open source. We built S3 atop Tomcat in the early days. We built EC2 on top of Zen. It is critical dependency. It's also important to our customers. It's important to the rest of the world. We've talked about the 78% by volume that open source makes up of all modern software. And so we've got this long history where we have a shared destiny, along with all of you, with the open source community. And we have to make sure that there are healthy, vibrant open source communities producing good code.
We're going to talk about how we do that with 3 pillars. But prior to that, short digression, could do a whole talk on this. Maybe next year we'll do this, which is a little bit about how we, AWS, we consume open source and how we think about open source consumption. First of all, as with all security properties of AWS, we tell builders, you are responsible for the security of your service. The security team is here to help you, to guide you, to give you tools, to give you code reviews and design reviews and threat modeling tools. And finally, we'll give some application security reviews at the end and finally say yes or no when you believe you're ready for release. But in general, we want to delegate and believe that engineering teams are fully own their security. And that includes the security of the open source dependencies that they take. So if you decide to use open source, we want you to bring that into our systems and take responsibility for that. And you become the team that, hey, you imported it, you own it kind of thing. And that is we think, a pretty healthy thing. Other teams might then be able to use it. But at least there's one team that sort of is on the hook for reasonable maintenance of that. Again, there's more we can do in this space. We're always trying to make improvements, but that's the concept, and so far it's worked pretty well for us. Builder experience, we do have a central team that manages our central code repository, build tools, and so forth and so on. Vast majority of our services are built using those central tools. And that framework also is very helpful from kind of a monitoring and tooling perspective, because there we can track the dependencies. We have this very complete understanding of all the dependencies across of our massive fleets of all these different services. So for something like Log4J, we quickly knew how bad the problem was because we pretty much knew where it was this questionable code was executing. And then we could also analyze by risk factor, obviously internet-facing systems, highest risk, and then sort of down through the back layers. But the really nefarious thing about that particular bug is, you could be down on some Windows desktop somewhere analyzing a log file, and if you have the vulnerable, software. Now, it's only going to, maybe infect that one local system, so it's not necessarily as big a deal as affecting a cloud service, but still, it was really, really problematic. Anyway, by having those central tools for building and deploying software, again, we try to make the safe path the easy path, because if you do come into this environment, which most of our developers do, we have all these really nice tools, especially for deployment management, which is a huge challenge in a huge global cloud platform. And we can also do central things like run, code scanning tools and so forth in that central tooling system. And that's, security engineering, a security team where I work. We support these things as essentially an internal consulting organization, but also a kind of checkbox of last resort. Yes, you do have to sort of get our permission to launch your thing. But if we ever say, as long, reInvent is approaching, right? And there's a lot of pressure to get your service out for reInvent. But if we ever reach a point where we have to say to a team, you know what, we have a couple high severity findings here, a couple mediums, this is not ready. That's a complete failure as far as we're concerned. Like, that should never happen. It seldom happens, and when it does happen, we consider that a failure. We literally write a correction of errors, like a COE, like why did we get to 4 weeks from launch, and only then decide that we don't agree whether you're ready or not. That's bad. We should never do that, because you really want to build this in as early as you can into the process. That's just a brief snippet. We can talk more about that at some point. And in the middle, we have our open source program office, which is coordinating how we interact with the outside world around open source, making many of the investments we're about to talk about. And that's also a critical part of the overall picture here.
So we think of open source as having really 3 key pillars. And those are the focuses that we take when we're trying to improve the state of open source supply chain security. And those are work upstream, release our own security frameworks and tools, and of course provide financial support for the places that we're involved in. So first, we do a lot of work upstream. We are, I think, the 4th largest contributor to OpenJDK. We have dedicated teams focused on the Rust programming language, including some of the Lang co-leads. We've got a dedicated team that is working on PostgreSQL. They are the number 2 largest contributor of code, but the thing that I'm most proud of is that they are the number 1 reviewer of code coming in to the PostgreSQL database engine, meaning that they are doing more code reviewing than anyone else. And frankly, that code reviewing is probably more important than actual contributing. I would be remiss not to call out Valky. If you haven't heard about Valky, please pay attention to the open source expo on the expo floor. Valky is a new fork of the Redis database that has preserved the BSD 3-clause license, so it remains open source, unlike Redis now. But we've got dedicated teams that are doing lots of upstream contribution, and we think that it is important to identify the projects that are critical to our ongoing success and to our customer success, and making sure that we're investing in them by actually being the contributors, the authors, the reviewers of that code.
Pillar 2 is when we build software that in the security realm that has, we believe, an insignificant security impact, we'll try to release that as open source so that other people can benefit from that as well. I would love to give a talk on, I could spend a whole hour on just this one slide, and I won't do that. I'll call out a couple of real quickly. Well, I'll kind of go in sort of reverse order. So OCSF, everybody should be aware, there's a huge momentum now around a security logging standard, a standard for what kinds of information should be written into the security telemetry coming from security tools. We have like 150 companies all signed up to either emit or consume OCSF, and finally try to get out of the data munging problem that's really badly challenged our industry from early days. CEDAR is an open source authorization language, formally verified. The language is formally verified. The implementation is formally verified. It's all open sourced. And we encourage you, if you're writing the equivalent of an access control system, please don't write another one. Just use the open source one we have. BottleRocket is some open source framework for running secure containers on a very locked down version of Linux so that you maintain the security properties of things like read-only file systems and all these things that make it much harder to have a bad day in your container environment. Firecracker is the micro VM technology that underlies our Lambda service, but many people in the industry are using now. They're full hardware-based KVM virtual machines. But they can boot and run user space code in 1/8 of a second. So from the time you say launch VM to the time your code's executing inside that VM, 125 milliseconds. So you can use it in places where you might have been tempted to run a container as your packaging technology, but believe me, if you're a security professional, you know containers are not a good boundary between untrusted workloads. And you can use instead Firecracker as we do. And the last one I'll call out, last two. So raise your hand if you know what Quick is. Q-U-I-C. A few people. HTTP3, ever heard of HTTP3? It's sort of more or less synonymous, so not quite the same. Quick is a part of HTTP3. So guess what? The industry has invented a completely new protocol for HTTP. And they've taken two very well-defined, battle-tested, hardened layers, HTTP and TCP, and they've munged them into one. And so now HTTP runs on UDP. So there's unreliable datagrams being flying around the internet, and all the state management, packet tracking, packet numbering, head-of-line blocking, all that stuff is done now in the Quick protocol, and it's way more efficient. If you collapse layers like that, and you're willing to do the massive, difficult engineering work, if you have all the semantic knowledge of how you want a network to behave, then just sending datagrams around is by far the best thing to do, except that it makes your engineering that much harder because you have to recreate TCP in your code base. And so that's what Quick is. So again, please don't write now, most people don't have to worry about this. You're not system developers, but please don't write another version of Quick. Use ours. It's written in Rust, formally verified. Integrated TLS 1.3, integrated our libcrypto library, which is another open source thing. And quickly, Connie is a open source implementation of a formal verifier for Rust software. So another nice win. So again, we're running out of time, but this is actually one of the most important slides. So David, give it your best shot in 2 minutes or less.
Okay, in 2 minutes or less. AWS has to support the most important software to us, and we try and do that via code. We try and do that by releasing code that we've already found valuable internally, but we also recognize that we can't do it all and that we need to support some of those organizations. So AWS today sponsors or is a member of roughly 80 plus open source foundations and organizations. These range from security-specific things like OpenSSF and Prosimo to the Apache Software Foundation, the Linux Foundation, the Cloud Native Computing Foundation, and scores of others. And so we're trying to make sure that these environments where open source is built remain vibrant and healthy.
Last year, if you were here, we talked about the $10 million commitment we made over a 3-year period. We're coming down to the end of the second year, and I think we spent about 2/3 of the money so far.
We have.
Okay. So
no, actually, I think we spent 3/4 of the money so
nice.
far.
Okay. So it's been a great investment, and we've got some really good results. And it creates a flywheel because as other companies see we're investing, then they'll invest. And so really excited to see the progress there. So good stuff. So join us in creating a healthy open source environment and ecosystem. We talked a lot about dependency management, so be thinking about that, looking for healthy projects, use that scorecard technology, and also stay up to date, update your dependencies, update your software, and together we can build a very, very healthy and successful open source future.
And if you want to learn more, you can scan the QR code or go to this URL. We'd love for you to see more of what AWS is doing because there's so much going on that an hour really isn't enough to talk about it.
Next year we'll do 2.
Next year we'll do 2, I think. Thank you so much.
Thank you so much.
I know it's been warm in here.